Very good. I think we can start. So hi everyone, and welcome, and thank you for joining us today. So we are here with three experts from two different companies, and we'll be hearing from them about database migrations and disaster recovery strategy. So we'll be talking about this topic and discussing also in the Q&A session. So I will start by sharing my screen and we can start. Very good. Can you see my screen? Very good. Okay, so this is the topic of today, and we are starting first of all with some reminders, so you can turn on uh, the subtitles, so in any language that you wish, and also I remind everyone that you can add any question, comment to the Q&A section on the bottom, and also reminding everyone that we will be sharing the recording the next day, so it will be also uploaded on YouTube. So my name is Elias, and I work at DB since 9 months, and I am territory manager for Southern Europe, Middle East, and Africa. And I look after our partners. So I manage the partnership ecosystem and the business development in the region. Here with me, my colleague Jan Klinke, our expert in disaster recovery, solution consultants. So Jan have been working at DBVisit since many years, and he's our expert on Oracle and also SQL Server and PostgreSQL. With us, we have our co-presenters, Ali Nawab, senior database administrator at the company DNT, and Sadek Astane, senior data and AI engineer at DNT. So we are going to present you this topic that we noted that it was a great discussion where we can share our knowledge and also share with you what we noticed in the market. So we saw that database migrations have become more and more common, and so more and more organizations will be migrating for multiple reasons. It can be for modernization, for moving to Postgres, for upgrading version of Oracle. And we noticed something interesting that during these migrations, it's a great opportunity to reassess the disaster recovery strategy and the infrastructure and the licensing. And this is the topic of today, where we will be discussing in two main parts. So the first part, where DNT will be presenting about migrations, and then Jan will be talking about the reassessing of disaster recovery and all the licensing part. So I'll pass it over to DNT after a quick presentation about DBVisit. So DBVisit is a company based in New Zealand. We have more than 20 years of experience in disaster recovery, and this is it's a company that is focusing mainly on disaster recovery for Oracle, Postgres, and SQL Server, and we support more than 2,000 customers in the world, over 120 countries. And I will pass it over now to DNT, and I will let them share the screen, and we will start with the webinar.
Hello, everyone. This is Ali from DNT. Okay. So today we are going to go through all the. Elias, can you hear me?
Yes, we can hear you.
Yes.
Okay, perfect. Okay, we are going to go through modernizing database. Modernizing database, Postgres from Oracle to Postgres migration, and minimizing the downtime. Today, we will talk about how organizations can modernize from Oracle to Postgres while minimizing downtime and ensuring business continuity. Executive contents. This is all about cost, which is very valid point. Beside that, there is cloud readiness, uh, cloud flexibility, and hybrid environment are environment and standalones. So as we can see, changed. As we can see in many environments these days, we can see multiple platforms running at the same time. One is running because of one particular software, which cannot be deployed on another database platform. And another one is because of the cost, like for what is that? Business intelligence tools that people use. Okay, Hyperion, if you want to use, it's super costly. On the other hand, people are doing Cassandra, which is for free, but it asks for different environments to be running on the market. So market reality. So to be realistic in the market, Oracle is still the mission critical database in the market all over the world. There is no question. At the same time, Postgres adoption is accelerating rapidly. So is the reality of coexistence. So, like if all the mission critical applications are running on Oracle, as I told before, like Cassandra or Kafka, business intelligence tools. Sometimes people switch, like the environment that I have seen in Bologna, Italy. Uh, they were using Oracle as their financial system, but for their BI system, they deployed Cassandra on dataset 4 at that time. It was dataset 4 as the backend database, where they can expand the servers horizontally instead of vertically. So there is a lot of scope. Oracle modernization path, cloud migration platform transformation, license optimization cost optimization, managed service and operation excellences. So these are the modernization path. Some people choose for license optimization. Some are opting for managed services. They only want 10 gigabytes of transaction, and they pay for those, and then they don't care how much man hour it is taking for a company, which is the supporting company, which is taking care of the database. So that is another architecture. So why Postgres? First of all, the cost reduction. Uh, in these hard times for everyone, like every other week there is another financial choke point, or there is another financial crisis. So the first thing, whatever company they want to do a migration, they want to do a transformation, the first thing that they will ask, how much? And after that, there is vendor lock-in. If all your applications are in residing in one architecture, then it's really getting into yourself into a vendor lock situation, where whatever licensing price they are going to ask, you need to comply. There is no escaping. So breaking that that chain. And cloud readiness. These days, everyone wants to move to cloud. They want to reduce their operational costs and transfer everything on the cloud. So the migration scope is not just about moving data. It includes ETL pipelines, applications, and performance tuning. Like we did a migration, and the other day, yesterday, we were having in a table we were having data A. Now we realize that it's not data A, but it's data A.1 or data A.5. So these are the technicalities that needs to be considered well before doing a migration or keeping in mind. And then it's a full ecosystem. So if we are going to do a migration, it's uh, it's not like moving only the data. Beside the data, there is 100 other things that needs to be considered while moving a database. Okay, moving forward, application migration approaches. There are basically two very common: offline and online. Offline is very simple, uh, which which is very robust, but it is the downtime it involves is way too high, which is not acceptable by most of the companies. And if we are doing online um, migration, it is more complex, but the downtime is minimizes. And downtime is the biggest risk for any business. So these are the things to be considered. Key risks: downtime underestimation. Like there is a company who says, "Oh, I will do the all the migration, but downtime will take only 2 hours," without calculating anything. And on the migration day, they realize that it is not 2 hours, but maybe 36 hours. And the second key feature, the second not key feature, we can say very important point, is data consistency. Like I said a moment ago, if I was having data A in our previous database, and after migration, if I'm having data 1.1 or 1.2, then this is not a successful migration. It is a waste of time migration. Application issues, we need to consider the application connectivity, all the web services, all the in-house development or external applications which are connecting through web services or Windows services or Linux daemons to our database. All that need to be addressed during the migration. Uh, Business impact. So, business impact, if uh, migration is not planned well, there is revenue loss, operational loss, and one that no business want to have is reputation damage. They can afford revenue loss to a certain extent. They can afford operational disruption, but reputation is something that businesses don't want to lose at any point of time. Moving ahead, continuity model: before, during, and after migration. Before, so before migration, as we were saying, that we have a situation like we have a database which is not supported anymore, uh, which needs to be transferred to a newer version. During this period of transformation, how we are going to work, and after the migration, how we are going to support this new life management system of this new database and applications. And during the same thing, replication and DR requirement, DR, our disaster recovery. While we are doing these things, we do not want to disrupt our replication and we do not want to disrupt our disaster recovery. Like we started migration, and during migration we stopped our replication or DR. And during the migration, something happened. We lost some data. Then we will be in a very tricky situation. So uh, before, during, and after migration, we always need to keep in mind the replication and DR requirements, how they are going to be fulfilled. Here comes the database replication and DR, disaster recovery, DB visit, standby by PM. So basically, DB visit support Oracle to Oracle, Oracle Postgres to Postgres, enables zero time downtime migration, simplifies hybrid environment management, reduce risk during critical phases. So this is for guaranteeing that if one point of failure does not mean complete loss of data, does not mean complete loss of operational activities. We can just switch over to site B, and we can uh, keep continue. We can keep continue our business. Collaboration model, database, database and technologies. We specializes in migration strategies and planning, ETL and data transformation, from Oracle to Postgres execution. DB Visit enables continuous replication, disaster recovery, safe control, turnover, cutover. Delivering successful migration together. Combined approach, minimum downtime, as we have expertise on both sides, from a replication and disaster recovery side, and from the migration team, with both sides having at least 20 plus years of experience in the field, with Oracle, Postgres, migration between them, and replication, to reduce the risk, full control throughput throughout migration. Hybrid complexity, like if we are having one technology, Oracle only, we will have less complicated environment instead of having multiple. Like uh, I have seen in different platforms, they are using multiple. As I gave an example earlier, they are using multiple platforms for multiple purposes. Like their main transactions, they are happening in Oracle for revenue generation, but the Hyperion is expensive. They want to do Cassandra for BI. They want to do Microsoft SQL for Microsoft ERP. So this increased failure points. This increased failure points, but with the help of our experts and the DB Visit replication tools, we can always depend that there is a disaster recovery which will take us out of the situations. Customer journey, preparation, migration, cutover, post migration. So this is the basic life cycle of a database. When you start preparing, what are the things which are let's suppose degraded from the previous version to the new version? What are the things that I cannot do anymore which I was doing? What are the things that I can do better that I was doing in the previous version? Then there starts migration. In the migration, during the migration, there is very regressive testing. That if I am having a data A in my in my source database, I should have in destination database A, not one A.1 or A.2. And once everything is uh, there is after migration, there is parallel run, cut over, and migrate post migration, that we need to decommission those stuff and rebuild. rebuild our disaster recoveries for the new environment. Uh, Architecture overview: Oracle, replication layer, Postgres. So from Oracle, there is a replication layer. We can do a replication from Oracle to Postgres. And then the standby in the meantime is working to keep our systems alive. Like if some cyber attack happens, or if there is some downtime on the main source database, we can switch to disaster recovery for business continuity. Key takeaways. Uh, the key takeaways from this migration plans is to minimize the downtime, control risk, that we identify the risk before it happened. It means that when the risk when the event really happens, we know how to react and how to overcome. It's not like it becomes a surprise for us. Hybrid is the future, as I have mentioned. Like Oracle licenses, they are not so cheap. For every other tool, if we are going to keep buying licenses, it will pile into millions and millions. Architecture review, migration assessment, product demo, that can be delivered upon request. Sadiq.
Okay. Hello, everybody. I'm Sadeg, and I come to starting to sharing. Okay, can you see my screen? Yeah.
Yes.
Okay. In the new era and in the context of AI transformation, in the context of traditional data migration, it's very slow and expensive and risky because organizations operate in environments that are complex and constantly changing. Several challenges make the process difficult and resource intensive. In the context of AI transformation data, migration from slow and manual activity into a streamlined, intelligent, and highly automated process, because many of the tasks applied in the migration are reproducible in different tasks and running in parallel or in a sequence, depending on when you need to optimize it and reduce the time for this context. At every stage of discovery, mapping, code conversion, validation, and orchestration, AI reduce effort, increase accuracy, and accelerate timelines. Below is detailed breakdown of how I enhanced each part of the migration journey. In this context, you can see we have a few steps to using for this, and we can to starting to automation of the process. In the context of automation, conventional discovery make the engineer performs the conventional make to reducing manual inspection of the columns and tables. In this case, that's possible to go into automation of the inspection of the table, columns, scheme, and lineage. AI automates this process by scanning database, table, schemes, index, and metadata, detect hidden relationship and table dependency, automatically identify lineage across ATL jobs, storage procedure, and pipelines highlighting high risk object that required special handling. And this automation discovery significantly reduced the time needed to understand the legacy system. Second step is intelligence scheme mapping. Scheme mapping is one of the most labor intensive tasks in the migration. I simplified this by using NLP models, because we are going to using natural language processing models to understanding columns name, data types, and description, matching source columns to target fields, even when naming convention differ, suggesting predictive mapping based on historical patterns. In many cases, this reduces manual efforts by 60 to 80 400, making this the process faster and more consistent. The third part of the steps are code conversion and ETL reinforcing. Migration scalar logic, store procedure, and or ETL code is major part of this step. By converting SQL from legacy engine to Snow, for example, Snowflake, BigQuery, Fabric, Databricks, from any type of the database to another database, rewriting Python, Spark, informatics, or other type of talent pipelines using LLMs, that's possible. Modeling the LLM and ETL by logic from ETL into ALT patterns, suitable for cloud warehousing, and so on. Other steps for data quality and anomaly detection, answering clean, consistent data is crucial. AI enhancing quality checks by detecting missing value, duplicate outliers, and patterns deviations, identifying schemes drift when new fields appears in the scheme, such as normalization, standardization, or enrichment rules. This created a strong foundation for accurate and reliable data migration. In the five steps, test case generation. Manual testing is slow and often incomplete. AI improves validation by generating test script based on a scheme, a lineage, and business rules. Creating reconciliation scenarios for raw counts, aggregate, and referential integrity, automating comparison between source and target. This answer comprehensive testing without extra effort. In the sixth step, end-to-end orchestration with AI agents, the biggest leap in migration comes from AI agents that execute multi-step tasks autonomous. Copy data, for example, copy data from source to target, validate and correcting error, running failed jobs, deploy transformed pipelines, human in the loops, appropriated answer, safety for critical operation. And in the using this context, that's possible to applying privacy and GDPR for anonymization of the data and supporting this context. That's all of possible to using AI for this context.
So sorry to interrupt, Sadek. Just reminding you that it's 3:30, just to make sure that we have enough time for the next part and the Q&A session. So if you want to conclude with the remaining slides, and we can pass it to Jan.
Okay. That's moment. Okay, I have stopped by sharing.
Thank you, Sadek. Thank you.
Okay.
So Jan, if you want to take over.
Okay, I'll show my screen. Hopefully you will be able to see my presentation.
Yes.
Okay, awesome. So again, good afternoon, everybody. It's good to have you here. And yeah, thanks very much for making the time to hear all of our presentations. I will pick up where Elias left, and my presentation is related to what you heard already. It's just that my presentation is not focused on the migration itself. It's rather focused on things related to the migration. And one thing which is related to the migration is always or usually the review or the planning for the future infrastructure. Every migration is really big opportunity to reassess or assess your requirements, your capabilities, and plan the future infrastructure. DB Visit company is really focused on disaster recovery, and our single and most important job is to help customers to make their environment more resilient. And increasing resiliency is one of the main topics for every migration, especially now that you have wars, cyber attacks, and a lot of other threats. And that's why we, as a company, are involved in migration projects a lot. We don't do migrations like themselves. We are not related to that. We are really related, and we are helping our customers in increasing resiliency of their environment. So that's just like an introduction. So I would like to present to you some ways how you can increase your resiliency after the migration or when planning the migration. And my background really is Oracle DBA. I don't really work much with Postgres or SQL Server. So apologies that my presentation will be a little bit biased towards Oracle. Yeah. So when you are evaluating your resiliency, let's say for the future infrastructure, the good place to start is actually, or the good way how to look at it is actually to go from the top to the bottom. So first, you should always assess your business requirements and what your business really needs. And then you could or you should progress gradually to the bottom, to the technology itself. So typically, whenever we are engaged in conversation with customer, we would ask them like, what are your business requirements? And based on that, we would be able to suggest, let's say, appropriate infrastructure or appropriate deployment type for them. The two most spelled or used variables in this whole planning are RPO and RTO. RPO is essentially your potential data loss. RTO is essentially the time which you need to get back online. In previous years, I started my career like 2007. RPO and RTO, it was very usual that they were, measured in hours or even days. Nowadays, the business or most business applications are becoming more and more critical, and those two variables, RPO and RTO, are really getting closer to minutes when business talks about them. And in order there is a price tag to it. So, for example, if you would like to have zero data loss for Oracle, you would need to go for and those four methods are, I would say, in summary, what you should plan when you are thinking about your future infrastructure. It's never that you would be choosing one method over another. In most cases, or ideally, you should choose all of them, or at least combination of three of them, let's say, because they are not really, competitive against each other. They are rather complementary. So first you have the backups. That's something which everybody should do. Nobody should skip backups. Every production database, every production environment should be backed up somehow. But unfortunately, the backups are, I would say, very cumbersome and they have their flaws. But nevertheless, they should be your foundation stones. On top of backups, and this came recently when there were a lot of cyber attacks related to encryption, you should have air-gapped backups. And what this really means is that once you make a backup, you essentially put it on some media or to destination, which is then disconnected from the outside world, so it cannot be modified. It's essentially like an immutable backup. And again, it was not really. I haven't heard this term in, I don't know, 5 years ago, 6 years ago. But currently it gets more and more frequently discussed. Then you have a cluster, which essentially means that you have multiple nodes which form a cluster, and whenever one node goes down, the other nodes can take over. An example of a cluster for Oracle is Oracle Real Application Cluster or Oracle Standard Edition High Availability. And for Postgres, for example, it's Petroni. Cluster is something which is used very frequently. It's only that each technology, Postgres, SQL Server, and Oracle, they approach it a little bit differently. And last but not least, you have the standby database. And the idea of standby database is essentially that you have a completely separated remote location with completely separated storage, and you can use this remote location in case your primary goes down. It could seem as if this would be the perfect solution, but it's not really the case because standby database has also its disadvantages. But in terms of resiliency, it's true that it gives you the most resiliency of everything. When you look at the details of the backup, basically, I will try to focus on the two points I said before, RPO, RTO. So backups, as I said, you should always do them. Their problem is that they have really big RTO, really big RPO, and it's always difficult, if not impossible, to test the backups. And even if you test backup, it doesn't really ensure that the next backup you take will be good as well. So those are the limits of backups, but despite those limits, you should really be using it. There's no such thing as replacing backups by some high availability technology. Backups should be always there. Airgate backups are essentially like a, I would say, more cumbersome version of normal backups because once you get them somewhere and disconnect them, it will just add the RPO, it will just add the RTO on top of the existingly big RTO of the backups. But the good point or the good thing is that they cannot be really modified. In a lot of cases, if you have cyber attacks, the cyber attackers would really wait until, like from the moment they infiltrate and infect your environment, they would wait for 30 days until you have no longer backups, and then they would, start a ransomware attack. Airgate backups really prevent situations like this because they are usually long term and they are isolated, so they cannot be encrypted usually. Clusters, this is what I already a little bit described. For clusters, you have several different technologies. I think for Postgres, I haven't mentioned Petroni cluster, but in case of Petroni cluster, like if you look at Oracle clusters and also SQL Server cluster, um, the, the main concept is that they have shared storage. So while Oracle and Windows cluster can really switch nodes very, very fast in a very fast and repeatable way. Underneath, there is just a single storage, just a single shared storage. And if this storage fails, the cluster will fail as well. That's not the case of Petroni, which is exclusive to Postgres. And Petroni is actually kind of like a standby slash cluster because it combines a clusterware on top of separated servers. So each server in a cluster has actually like dedicated storage. There's no shared storage. And that's what really makes this solution very resilient and very, very capable. Unfortunately, it's also very complex to set up, to administer, and to maintain. So long story short, the clusters are really great. The only disadvantage is that they will, if we consider Oracle and SQL Server clusters, they have the storage as a single point of failure. When we look at the standby databases, because they have dedicated storage on the primary or on the source and on the target, they completely eliminate the storage as a single point of failure. And you can be sure that even if your primary data center goes down, or even if somebody deletes accidentally your whole database, you still have a copy in a remote data center. And the standby database as such is always like active. It's always in sync with primary, and you can verify its contents and its readiness at any point in time. That's big improvement, for example, over backups, which you cannot really verify. Standby database is always there, always running, so you can, at any point in time, take a look and verify if it's ready to be used or not. But the big disadvantage of the standby database is that because the storage is not shared, once you actually activate standby database, once you use it as a new primary, and once you start inserting production data into it, you cannot really switch back easily, or you cannot fail back easily. That's just impossible. And when you really activate standby database, when you perform failover, the failback will always require you to rebuild the old primary from the scratch. There's just no way around it. And this is how it works with Oracle and SQL Server. Postgres has a very neat way to get around it with PG Rewind. But in fact, it's sort of like a rebuild. Yeah. Okay, here is the comparison table. It basically summarizes what I've said so far. I guess we could focus on the RPO RTO. Again, backups, absolutely terrible RPO RTO. cluster usually 0. But the problem is the shared storage as a single point of failure. And the standby itself, or the standby, has really good RPO, really good RTO. The only disadvantage is that after failover, you need to rebuild. So failover is really fast. Our RTO is really like in a matter of minutes, but the failback, that will take time. Failing back or during failback, your business is not down. It's still up and running, but yeah, it takes some time until you are ready to fail back. And there are other properties I would like to talk about, but yeah, we don't have much time, so I'll just skip it. I said that my presentation is biased towards Oracle, and here I have a graphical representation of typical Oracle clusters, or of 2 cluster solutions for Oracle. One is for Standard Edition, one is for Enterprise Edition. And I should say that Oracle provides this cluster or clusterware free of charge. There's really like no cost included. It's only, or you only have to license the servers for the database. So while the cluster itself is free, it's really a separated product. It's Oracle Grid. If you would like to run Oracle database on such cluster, then you have to license the nodes for the Oracle database. So on the left, you see Standard Edition, high availability, and essentially Oracle, the way it works is that 2 servers form a cluster which has storage, where you have some sort of voting files, and the cluster mechanism will decide which node is correct or which node is not correct. And very important is that this kind of cluster is active-passive. So if you have an Oracle database running on that cluster, the clusterware itself is active on both nodes, but the Oracle database runs only on one. And when one of the nodes goes down, this means that Oracle clusterware will attempt to start up the Oracle database on the second node, which is great, it works, but the problem with this approach is that it takes some time to start up the Oracle database on this second host, and it adds up a little bit to the RTO. It's only a few minutes, but it's still there. Nevertheless, if you would be using Standard Edition, if you would be planning to maybe go to Standard Edition, this Standard Edition high availability is a really good solution in my perspective, because it's a cluster which is kind of easy to install, and you have the basic protection for your database. For Enterprise Edition, Oracle offers Real Application Cluster, and the Real Application Cluster is an add-on option to the Enterprise Edition itself. So not only you have to pay for Enterprise Edition, you have to also pay separately for the Real Application Cluster license, making this really expensive solution. Funny thing is that it looks almost the same as the Standard Edition high availability. The only difference is that you have the Oracle database running on both nodes. So if one node goes down, the second node is already there. So all of the sessions which were connected to this failing node and which failed when this node went down will be able to immediately reconnect to the second node. And this is what Oracle defines as a 0 downtime. So the RTO in this case is really 0. Here I have, moving away from the clusters, this slide shows you the solution with standby database. As I said before, standby database, the biggest distinguishing factor is that you have the local storage for each of the hosts. So primary host has its own storage, standby host has its own storage, and they are not synchronized in any way. The only synchronization which happens is on the database level, and it's basically replicating transactions from primary to standby. Very good conceptual thing about this whole concept is that the synchronization itself is not really demanding when it comes to network bandwidth or latency. You can really have primary and standby side in very remote data centers, and standby host would be still in very good position to take over your production load if the primary database or primary host would go down. Again, you have the option to do this with Standard Edition and Enterprise Edition. Enterprise Edition has DataGuard, which is actually built in or included in the Enterprise Edition license. So you will not have to, or you don't have to pay anything extra. It's already included. The only challenge is then to set it up correctly and maybe to maintain it. For standard edition, I have to say that no solution out of the box exists for this type of synchronization. And you have essentially two choices. Choice number one is to do it manually. So if you are, good with scripting, if you know Oracle database, if you know Linux, if you know Windows, you can just script the whole replication with archive logs and you could be fine. But this solution is very basic, and you will find yourself in very difficult position when it comes to various, exceptions and various situations during the daily workload. Because scripting the synchronization itself is not really hard; it's very easy. But all the situations which comes, they are the ones, or they are really difficult ones. Because, for example, what happens when you add a new pluggable database, when you add a new data file or a new table space, and so on and so forth. So this would be number one option if you don't want to spend anything extra. Number two option would be to use our product, DB Visit Standby, which is essentially, Elias said it in the beginning, we are on the market for 20 years. And for 20 years, we have perfected this sort of archive log synchronization, archive log or transaction synchronization. So in our product, we already include like everything possible, every situation, every exception possible which can happen between or in this type of replication. So if you would go with our product, yes, there is some added cost, but basically then this sort of replication, this sort of disaster recovery solution would be completely maintenance free for you, almost. There's always a maintenance, but we would really minimize it. Okay, I think, yeah, okay, and here's a little bit of screenshot of our product. We essentially are able to work with Oracle, Postgres, and SQL Server platforms, and we give users this nice graphical user interface which you can use to basically administer the synchronization, the DR solution. And for all three platforms, it more or less looks like this. You have the primary, you have the standby, and DB Visit essentially manages the synchronization on transaction log level. Right. So we have, I think, last 5 minutes. So I would maybe stop at this point and leave a place for the questions. I also had this licensing, but it's a small part and we would not be fine with time. So I'll just stop right here.
Thank you very much, Jan, Sadeg, and Ali. So we'll wait for questions. I can see that a question. We had a question already in the Q&A, but it was answered by Ali. Thank you. Also, if anyone wants to jump and ask a question.
Yeah, seems no questions.
In the meantime, I will reshare my screen and remind everyone that if you would like to continue the conversation and learn more about this topic, so discuss with our experts at DB Visits or DNT to discuss migrations or your disaster recovery strategy, we can discuss in a separate call. So feel free to reach out to us. All right, I don't see any question coming in the Q&A, and I can see that we went a bit over time. So I think we can conclude this webinar. What do you think, Jan, Ali, and Sadek? Very good.
Yes, we can.
Very good. Well, thank you very much, Jan, Ali, Sadek. Thank you for your presentations. That was great, very interesting topic. And of course, as I said, we can continue the discussion in separate meetings. Feel free to reach out to us for any question, or if you. So I just saw a question coming in the Q&A. Sorry. So before closing, question from Sergio. Maybe that a customer wants to know during an attempt of migration, not only RPO, RTO to the migration, good results, but how long we can come back to the source situation, aren't it? So if you want to answer to Sergio, Jan or Ali or Sadeg, if you have a visibility on the question in the Q&A.
I have to say I'm not understanding clearly the question. I'm not sure how long we can come back to the source situation means. So maybe if you could rephrase it in some way, because I don't understand the question.
Sergio, if you want to unmute yourself and jump in, feel free to.
No, it's not possible. He would have to write it. Participants don't. Yeah.
Okay.
Come back to the. So you mean like when you do the migration and you need to fail back? That's what you have in mind? When migration doesn't really end up well and you need to go back? That's what you mean? Yes, okay. So I would just maybe share. So in the beginning, it was said that dbvisit can actually help you with migrations. And the way dbvisit does it is a little bit limited because you cannot migrate between database platforms and you cannot migrate between database versions. But you can basically use dbvisit for migration from, let's say, on-premise to the cloud, or to migrate from one data center to the other data center. And then the way the migration looks like is that you essentially establish the synchronization. You keep the standby database in sync. You can perform your tests. You can even do some iterations when you try to activate the standby database and you try to work with the data on the new site. And then if you're satisfied, you can just do the migration itself by activating the standby database. So essentially, if I go back to this picture, you would essentially like activate the standby database and try to connect your application. And if it's successful, then the migration is a success. If it's not successful, then you can actually reconnect your application back to the production, because the failover itself, it will not affect the primary site in any way. So if you use dbvisit for migration like this, when you establish the replication and activate the standby database as a migration, then the primary database will still be there. And if after activation you see any issues, you can simply just reconnect your application back to the original primary. But again, this approach is limited in terms of that you need to match platform, you need to match you need to match the database version. Yeah, this is the limitation. And in this case, the rollback time would be also like very low, because as I said, the primary database would still be there. So the failback would be, very, very fast, because you would not be like actually doing any harmful modifications on the old primary when you would just activate the standby database. Yeah, thank you, Sergio. Good question. Thank you. Okay, stopping the share.
Very good. Thank you, Sergio, and thank you, Massimo, for clarifying as well in the chats. I think we can close the webinar. Thank you very much, everyone, for joining. Thank you for your questions. And if you have any question and you would like any follow-up discussion, feel free to reach out. Thank you,
Thank you
everyone.
for your time. Have a good afternoon. Thank you.
Bye.
Bye.
Bye-bye.
Thank you. Thank you,
Bye.
everyone.